everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to be going over temperature conversions, and I'll show you some examples of that. So let's get into this. So when we're doing temperature conversions, we're either going to be converting between Fahrenheit and Celsius, or between Kelvin and Celsius, or between Celsius to Kelvin and Fahrenheit, right? So we can convert between any of those three scales of temperature. So we're going to be doing that by using these equations. So here are the equations that you would use to convert between different um, temperatures. So here, if I'm converting between Fahrenheit and Celsius, or between Celsius and Fahrenheit, if I'm depending on where I'm converting from and to, I'll be using one of these. Now you only need to memorize one of them because you can use algebra to convert to the other one, right? So I just want to point out a couple of things about this formula here. First, you'll notice the 32 here. In a previous video, I talked about the different temperature scales and how they're related to each other. And the difference between Fahrenheit and Celsius, one of those is that 0 degrees in the Celsius scale is where water freezes. But in the Fahrenheit scale, it's 32. So there's a difference in 32. So you're either going to add or you're going to subtract 32, right? So that's one thing to keep in mind. And also this 9/5. Sometimes you'll see that as 1.8, right? So if you take 9 and divide by 5, you get 1.8. Well, where does this 1.8 or 9/5 comes from? Well, if you remember from my video on the comparison of Celsius and Fahrenheit scales, you'll notice that the number of increments that the thermometer is divided into between your freezing point and your boiling point of water, that's divided into 100 increments for the Celsius scale, but then it's divided also into 180 for the Fahrenheit scale. So if you think about the 1.8 or the 9/5, that's going to be 180 degrees for Fahrenheit between freezing and boiling of water, and the 100-degree increments in the Celsius scale for between the freezing and boiling of water. So if you divide those, you'll see I have 180 over 100. That gives me the 1.8, or also the 9/5. So that's where this number comes from. It's basically a ratio of the size of the increment between your Fahrenheit scale and your Celsius scale. So because you have more increments, because you have the space divided into more increments, the increments are going to be smaller for the Fahrenheit scale compared to the Celsius scale. So you could say that the Celsius scale is 9/5 larger than the Fahrenheit scale. So that's where this comes from. Okay. For the Kelvin and the Celsius scale, their 0 points, the point at which water, I should say, before I get into that, I should say that the Kelvin scale, or the Kelvin increment, and the degrees Celsius increment are the same size. So the degrees or increments line up with each other, and so there is a one-to-one relationship between them. The difference is in the where the freezing point is measured, and so remember, we're going to add 273.15 to get Kelvin, or we're going to subtract 273.15 to get Celsius. We don't need this ratio of increments because, again, the increments are the same size. So it's going to be 1-to-1, and so it drops out. So basically, for the Celsius to Kelvin conversion, you just need to add or subtract 273.15. Okay, so let's go ahead and get into some practice problems, some example problems here. So number one, we have heavy water Heavy water, by the way, is water that is heavier than normal because instead of having normal hydrogen atoms, it has heavier hydrogen atoms in the water. Remember, water is H2O. So in this case, the hydrogens are made up are deuterium. They have an extra neutron, so they're heavier, and we call that heavy water. So heavy water freezes at 38.9 degrees Fahrenheit, and they want you to convert that to Celsius. So we want to go to from Fahrenheit to Celsius. So we're going to use this equation here. So here I'll write it out. So I have my Celsius is equal to the degrees Fahrenheit. Now the degrees Fahrenheit is 38.9 degrees Fahrenheit. So I'm going to put that in. So I have 38.9 degrees Fahrenheit, and I'm going to subtract 32, and then I'm going to multiply that by this ratio of Celsius to Fahrenheit. So here, since 32 is the number of degrees between the freezing point on the Celsius scale versus on the Fahrenheit scale, that's an exact number. So this is not going to influence your number of significant figures or your decimal points. So this has an infinite number of decimal places. So remember, notice we have a mixed bag or mixed operations here. So we have subtraction and we have multiplication. So remember, when you're trying to figure out your number of significant figures, you need to follow the rules of adding and subtracting or multiplication or division. But if you're doing all of those together, then you got to do your order of operations, and then you got to follow step by step what the rules tell you. Okay, so here we have 32 is exact. So we're going to subtract 32 from 38.9, and that's going to give us 6.9. So we got 6.9, and that's degrees Fahrenheit. And now notice here, again, because this is exact, the rule for subtracting and adding is that your answer, after you add or subtract, that answer has to have the same number of decimal places than the inexact value that has the least number of decimal places. So it has to have the same number. So this is exact. This is inexact. So this is the only number that we have to worry about. So since this has one decimal place, or another way to say it is that since the last digit of significance or the last placeholder of this measurement, this inexact measurement, is in the tenths place, then therefore your answer after you subtract should end up in the tenths place as well. So the last digit you're allowed to keep is in the tenths place. Your calculator might give you more digits, and you might keep an extra digit. That's what I usually recommend. Keep an extra digit after that one, but the last one that you will actually ultimately keep is going to be in this place here. So that's what we're doing here. This becomes 6.9. So my last digit is the 9. So, but we're not finished yet. Now we have our multiplication. So we have 5 degrees Celsius over 9 degrees Fahrenheit. And so now we have to multiply. So when we're multiplying, the rule is different. The rule now is the answer that we get here has to have the same number of significant figures, not decimal places, but significant figures as the inexact value with the least number of, or the fewest number of significant figures. So here again, we have, this is our 6.9. So I put a line, I'm going to usually put a line underneath the last digit to remind myself, okay, this is the last one. And so now I'm multiplying by this. Now this here is also exact. This comes from this, right? 180 and 100, these are exact numbers. These are counting numbers that come from the temperature scales. And all we're doing is dividing them, and we get this 5.9, which is a simplified version of 180 over 100. So this is exact. So when we multiply by this exact number, it's not going to have an effect on significant figures. So we can ignore this. This has an infinite number of significant figures. So then our answer here is going to be dependent on this inexact number, which has two sig figs, the 6 and the 9, and we stop at the 9. We can't go any further than the 9. So this has two sig figs. And so when we do this calculation, our answer is only allowed to have two sig figs. And then when we do that, our answer ends up being, let me double check, 3.8. Oops. Sorry about that. So this is going to be, oh, and by the way, we should cancel out the Fahrenheit and we get degrees Celsius. So there is our answer for this conversion, 3.8 degrees Celsius. Okay. What about number 2? Let's go ahead and do number 2. Okay. So in this one, we have 1 chloropropane melts at 46.6 degrees Celsius. What is the temperature in Fahrenheit? So now we're going from Celsius to Fahrenheit. So we're using basically the same equation, but now we want Fahrenheit and we're given Celsius. So we would use this form of it, which basically is the same as this equation, except now we've solved for Fahrenheit. So let's go ahead and get this started. So we have Fahrenheit. So the Fahrenheit temperature is going to be equal to Celsius. So the degree Celsius that we're given is 46.6 degrees. So we're going to put in 46.6 degrees Celsius. And we're going to multiply that by our, again, our ratio, but this time it's flipped. It's 9 degrees Fahrenheit. So we're going to have 9 degrees Fahrenheit over 5 degrees Celsius. And then we're going to add 32. Okay. So in this case, we're going to do multiplication and division first. So again, the rule here for multiplication and division is that our answer should have the same number of significant figures as the inexact value that has the fewest number of significant figures. So again, this is exact. So the number of sig figs for this is going to be infinite. So we're going to focus on this. And we have 3 sig figs, 4, 6, and 6. That's 3. So when we do the calculation, our answer here should only be allowed 3 sig figs. Again, we might keep an extra one to avoid rounding errors, but we're only allowed 3. So if we do this calculation, right? So again, the degrees Celsius cancel out. We're left with degrees Fahrenheit. And what do we get for that? That's going to end up with 83.9. So let me just go ahead and calculate that really quick. Okay, so when you calculate that out, you actually get on your calculator 83.88. And that's going to be degrees Fahrenheit. And then we're going to add to that 32. Okay, so again, remember, since this value here, this is the only inexact value that I'm working with. So this has 3 sig figs. So my answer after the multiplication and division can only have 3 sig figs. But notice I have 4 here. So I'm going to put a line underneath the 8 to remind myself that I'm only allowed up to the 8 as far as sig figs. But I'm keeping the other 8 to avoid rounding error. If I round too early in my calculation, I could end up with a slight rounding error later on, and that could tell me that my answer is wrong and I could be marked off for that. So make sure that you follow this procedure. So just keep one extra digit just to be on the safe side, but underline it to make sure that you remember that you're only allowed the 3 sig figs here. Now, why is this important? Because if I forget, notice that I'm adding 32. And remember, when you're adding and subtracting, the rule now is that your answer after you add and subtract is that the answer that you get must have the same number of decimal places that, well, let me state it this way. Your answer should have the same number of decimal places as the inexact number with the fewest decimal places. Or what I think is a better way to say it is that the last place of significance in your answer should be the same as the last place of significance of the least precise answer that the inexact value that you're using. Okay, so here, this 32 is an exact number, so it has an infinite number of decimal places. So it's very, very precise. It's as precise as you can get. Notice here that I have 2 decimal places here, but really I only have 1 decimal place because that 8 does not count. I should ignore that 8. The 8 there, the second 8 there is only there to avoid rounding mistakes, not to count as significant figures or decimal places. So here I have 1, 2, 3 significant figures. So then when I add 32, my answer should only have 3 sig figs. So I add 32 to this number here. So that's going to give me 85 plus 3 gives me 115. So then this is going to be equal to 115.88. But remember, I'm only allowed 3 sig figs, right? So this is 1, 2, 3, right? And I have this 8, that's just for rounding purposes. But notice when I add this, now I'm only allowed 3 sig figs. So I'm allowed, okay, the 1, and the 5, and notice the 8 there. So I have to cut it off at the 5. Since that's an 8, I round this to 116. So my final answer is going to be 116 degrees Fahrenheit. And so that is what I am allowed. Sorry about that. So I just realized my mistake. So my bad. Sorry about that. I lost track of what I was talking about. All right, let's go back here. So I was talking about sig figs here, but what I should have been, somehow I switched from decimal places to sig figs. So again, I'm here for decimal places. And so keeping that extra 8, I add, and then again, the number again here is going to be 115.88. And again, if I was thinking sig figs, I would have been right. But again, the adding and subtracting, the rule is decimal places. So I'm only allowed 1 decimal place. So that means in my answer here, I'm allowed 1 decimal place. Don't make the mistake I just made. I'm not looking at sig figs. I'm looking at decimal places when I'm adding and subtracting. So here, I add it together. I have 1 decimal place. I have 1 decimal place here, so I'm going to cut it off after the 8 here. And since I have that second 8 there, that's going to be rounded to 115.9 degrees Fahrenheit. So yeah, my apologies for that earlier mistake. I got sidetracked, and again, it just shows how easy it is. Even like a professional for me can get to forget what they're talking about with regard to decimal places versus significant figures. So don't make that mistake. Okay, so for number 3, we have silver melts at 961 degrees Celsius. What is the temperature in Kelvin? So we're now using this equation, these equations here. So we're starting at degrees Celsius and we want Kelvin. So here we're going to use this. We're going to add 273. So our degrees Celsius is 961 degrees Celsius, and we're going to add 273. 273.15, and that's going to give us our answer. So again, we want to pay attention to what we're doing here. So what we're doing is we're adding. So again, the rule is going to be the number of decimal places. So when I have here, this is my inexact, and here's my measure. Also, I have 2.73.15. I'm going to add that to 961 degrees Celsius. So when I do that, I get, let me see, that's going to be 1234.15, and that's going to be Kelvin. And so then from here, since I have my answer, I'm adding, and so I want to look at decimal places. So here I have 2 decimal places. Here I have 0. So my answer should not have any decimal places on it. So I would erase and get rid of that. And since that's a 1, that 4 would not change. That would stay a 4. Now, again, the other way to think about it is the least place of precision, or the last place of precision in your measurement. And so here, the last place here is in the hundredths place. Here, it's in the ones place. So the least precise one is the 961. So your answer should only have the same amount of precision as the measure that has the least amount of precision. So since the last place of significance is in the ones place here, and the last place is the hundredths place here, this is less precise. This is the least place. So then my answer should end at the ones place here. So I shouldn't have any decimal places. So then I would round that to 1, 2, 3, 4 Kelvin. And so that would be the answer that I would record. And then finally, for number 4, we have tin 2 sulfide. That's going to melt at 1155 Kelvin. What is the temperature at Celsius? So we're going in the opposite direction. So now we're going to use this formula. Basically, this formula comes from this one, or this one comes from this one, by either moving the 273.15 to one side or the other. So you can go back and forth between these two forms of the equation by algebra. So here, I'm going to use this one. So we have degrees Celsius is equal to Kelvin, which is in our case 1155. So 1155 Kelvin, and we're going to subtract 273.15. And then when we do that, what do we get? It's going to be that's going to be 882. And so, 882 or 881 or 882, I think, So 882, actually, sorry, did that wrong. 881.85. I forgot about that. All right, so we have 881.15. So again, we're looking at our rule, which is going to be the least number of decimal places. So here we have our last place of significance is the ones place again. Here it's the hundreds place. So when we add or subtract, we're only looking at the place of least precision, or the which place, which one has less places of significance or less places of precision here. So here we have the ones place and we have the hundreds place. The ones place is less precise, so our answer can only be up to the ones place. So when we count here, we had the ones place, then this 5, we have to drop everything after the 1. So the 8 here is going to tell us to round up, right? Because this is an 8. So our final answer is going to be 882 degrees Celsius. So that's how you get that answer there. So I hope this was helpful. Sorry about the mistakes that I was making earlier. Hopefully this was clear. And if you enjoyed this video and you learned from this video, then please, by all means, like, share this video with others. Hit that like button over there somewhere. And also subscribe to my channel. Help me out. Hit that notification bell. And when you do, make sure you click all, so that way you can be notified by all the videos I put out. And also put a comment down below in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me and have a great day.